Astronomers have identified another mysterious interstellar object speeding through our solar system. And this one is astonishingly massive, officially named 3I Atlas. It is racing along at more than 150,000 mph and could measure up to 12 meters in diameter, making it much larger than its famous predecessor. Oumuamua. Telescopes worldwide are eagerly observing its unusual glow, trajectory, and faint, misty halo, while some researchers assume it is a frozen fragment of rock or ice. Others speculate whether it could be something far stranger. Could this colossal traveler from beyond our stellar neighborhood hold answers that challenge our deepest cosmic assumptions? This extraordinary discovery unfolded in the final days of June 2025, when astronomers noticed this enigmatic visitor moving across the sky at incredible speed. Unlike ordinary comets or asteroids, 3I Atlas was quickly identified as an interstellar wanderer, the third of its kind ever confirmed. Its detection has captivated scientists, who immediately recognized its rarity. For centuries, astronomers have charted countless asteroids and comets orbiting our sun. But interstellar objects are virtually unheard of. Before the breakthrough of 2017, not a single one had been verified. With the arrival of 3I Atlas, humanity has now documented 3 within less than a decade, an astronomical rarity by any measure. This is not just cosmic debris passing by. It is a messenger from another star system, a tangible clue about distant worlds that may remain forever beyond our reach. The ongoing investigation into what it is and where it's headed has unfolded like a gripping cosmic mystery, keeping researchers awake into the night as they track its rapid journey through the solar system at a staggering 152,000 mph. To scientists, 3I Atlas is more than a discovery, it is a fleeting opportunity, a gift from the galaxy itself, carrying materials from regions we may otherwise never experience. Hashtag the discovery story. The chain of events began between June 25th and June 29th, 2025, when the Atlas system, a network known as the Asteroid Terrestrial Impact Last Alert System, was carrying out its usual scans. Based in Hawaii and South Africa, its mission is to constantly search the skies for asteroids that might pose an impact threat to Earth. On those routine nights, the system flagged a faint point of light drifting across the background stars. At first glance, it appeared to be an ordinary near-Earth object, marked down as 11PL3Z in the growing catalog. Nothing about it seemed especially unusual until more detailed scrutiny suggested otherwise. On July 1st, astronomers in Chile noticed something remarkable. The object wasn't behaving like a typical asteroid. Its orbit didn't align with paths tied to our sun, and its speed was far too high for a local solar system body. Follow-up observations on July 1st and 2nd confirmed the anomaly. This was not a native resident of our planetary system, but a transient visitor from far beyond. The investigation took a leap forward thanks to amateur astronomer Sam Dean, who revisited archived Atlas images from late June. His findings revealed earlier sightings of the same object, crucially refining its orbit and velocity calculations. By July 2nd, the Minor Planet Center had received over 100 official observations gathered from telescopes worldwide. Some images even suggested faint emissions of gas and dust, the signature of a comet. With this influx of evidence, astronomers officially named the object 3I Atlas. The 3I indicates it is the third interstellar object ever detected, while Atlas honors the system that first recorded its appearance. Paul Chodas, director of NASA's Center for Near-Earth Object Studies at JPL, emphasized just how extraordinary this discovery is. At its current velocity, he explained, there's no possibility that 3I Atlas originated within our solar system. Tracing its path backward points toward the galactic center, suggesting it emerged from another star system entirely, though which one still remains a mystery. The confirmation of a third interstellar object within such a short span of time has scientists questioning whether these mysterious visitors might be far more common than once believed. It is possible that they have always drifted silently through our solar system, unnoticed until recent advances in technology finally made detection possible. The current discovery, 3I Atlas, stands apart from countless local objects for several striking reasons. Its velocity is extraordinary, about 152,000 miles per hour. At that speed, a trip from Earth to the Moon would take less than 2 hours. Most bodies in our solar system move at a slower pace, held firmly by the pull of the Sun's gravity. This object, on the other hand, is not bound in the same way. Its sheer speed reveals its alien origin. Unlike comets or asteroids circling the Sun, its backward traced path does not close into an orbit. Instead, its trajectory leads outward toward deep space, hinting at a birthplace near the galactic center, though the exact star system remains unknown. Its brightness is another surprising feature. Harvard astronomer Avi Loeb noted that 3I is reflecting a remarkable amount of light. This suggests two possibilities: either its surface is unusually shiny or its size is immense. If its surface is dark like most space rocks, the object would need to be around 20 kilometers across to reflect this much light. Such dimensions vastly overshadow both of our earlier interstellar visitors. Oumuamua was thought to be about 100 meters long, while Comet Borisov measured roughly 400 meters. By comparison, 3I Atlas would be dozens of times larger. Adding to its intrigue is the possibility of comet-like activity. Some telescopes have captured what seems to be a faint halo of dust and gas surrounding it, a feature known as a coma. This could classify it as a comet, albeit very different from those native to our solar system. As sunlight warms the object, a more distinct tail may develop, which would offer important clues about its makeup. Its orbital path also adds to the evidence of its foreign origin. While local objects generally follow the flatter plane of our solar system, 3I Atlas arrives on a steep, plunging angle across this plane, highlighting that it did not develop alongside our planets. Each fresh observation deepens astronomers' sense that this object is not merely a rock drifting in from outside, is more like a capsule of ancient history, carrying fragments of information about a planetary system far beyond our reach. With each passing night, pointed telescopes capture details that may reshape how we view the wider universe. To grasp why this discovery holds such significance, it helps to recall the brief but remarkable history of past interstellar detections. Before 2017, humanity had never confirmed a single object from beyond the solar system. Everything observed had originated within our own neighborhood. Then, on October 19, 2017, astronomers in Hawaii spotted something strange with the Pan-STARRS telescope. The object, later named Oumuamua, meaning scout or messenger in Hawaiian, was like nothing seen before. Its shape appeared bizarre, possibly long and cigar-like, or perhaps flat and pancake-shaped, rotating in such a way that sunlight reflected off it unevenly, producing wild brightness shifts. Even stranger was its behavior as it moved away from the solar system. Rather than slowing, it gained a slight boost in speed. Inconsistent with gravity's pull alone, many attributed the effect to outgassing, where invisible jets of gas push an object like a rocket. However, others, including Loeb, suggested the daring possibility that it might be artificial, perhaps an alien light sail. Oumuamua disappeared quickly, denying scientists the chance for closer investigation and leaving behind far more questions than answers. The next chapter came in August 2019, when amateur astronomer Gennady Borisov discovered another interstellar body. Unlike Oumuamua, this second object was clearly a comet, complete with a visible tail, named 2I/Borisov in recognition of its discoverer. It was far easier to analyze since it was spotted months before closest approach. Measuring about 400 meters across, it was composed of familiar icy material, much like comets that orbit our sun. This suggested that the processes behind comet formation may be universal across star systems. While Oumuamua challenged every expectation, Borisov felt oddly familiar. Their stark differences left scientists both fascinated and puzzled. Now, with the arrival of 3I Atlas, a third point of data emerges, one that may help us determine whether Oumuamua was an oddity, whether Borisov was the norm, or whether both are part of a much larger spectrum of interstellar wanderers. The appearance of 3 such objects in under a decade, after centuries of detecting none, has made researchers consider a startling possibility that these visitors are far more common than once thought, and that technological leaps in recent years have simply opened our eyes to what was always there. Tracking the passage of 3I Atlas through our solar system is like witnessing a grand interstellar voyage in real time. An extraordinary journey that carries the mysteries of another world straight into our cosmic front yard. As of early July 2025, the newly discovered interstellar traveler is hurtling through space at more than 152,000 miles per hour. At present, it sits about 3.8 times farther from the Sun than Earth, placing it beyond Mars' orbit but still within the asteroid belt. Unlike native solar system bodies, it is not in orbit around the Sun. Instead, its path is hyperbolic, a one-way pass that will carry it through our system before sending it back into the depths of interstellar space. If astronomers attempt to trace its journey backward, its trajectory points in the direction of the Milky Way's core. Yet, locating its precise origin star is virtually impossible, since the galaxy has shifted considerably over millions of years. Like trying to identify which rain cloud created a single drop that has long since fallen. Looking forward, several notable encounters lie ahead. On October 3rd, 2025, it will swing past Mars, marking its first close pass with a planet and offering an ideal opportunity to see whether the planet's gravity makes measurable changes to its course. Then, on October 23rd, 2025, it will reach perihelion, its closest approach to the Sun. Even then, it will remain about twice as distant as Earth is from the Sun, sparing it from the extreme heating that can fragment fragile comets. This wide berth also guarantees that Earth faces no threat. In fact, our planet will be on the opposite side of the Sun during the encounter. By December 2025, it will appear closest to Earth, though still at a vast and harmless distance. Afterward, it will accelerate outward, slowly breaking free from the Sun's influence and resuming its long interstellar odyssey. This object is like a cosmic tourist on a temporary visit before resuming its endless voyage. Forged around another star system billions of years ago, it may have drifted across interstellar space for millions of years before arriving here by chance. Soon enough, it will exit as quietly as it entered, continuing on toward unknown destinations, carrying the silent record of its meeting with our Sun and planets, a record that may never be discovered unless intelligent life in another system one day encounters it. For the scientific community, this is far more than a curiosity. It is a treasure trove of information. Until recently, every asteroid, every comet studied originated within our solar system. The arrival of this object brings direct material evidence from entirely different conditions of planetary formation. It is like holding a piece of another system in our hands without having to travel across the stars. Its larger size compared to earlier interstellar visitors makes this opportunity even more valuable, as it allows researchers to gather clearer observations, richer spectra, and more detailed measurements than were possible with Oumuamua or Borisov. If the object's faint haze truly signals comet-like behavior, scientists will be able to compare its gases, ices, and dust with those of local comets. The answers could illuminate whether the chemical building blocks for life as we know it exist in abundance across the galaxy or are unique to our home system. Timing has worked in science's favor as well. Unlike Oumuamua, which was already departing when identified, this object was detected months before its closest approach. This long lead time grants astronomers the chance to deploy a wide range of telescopes and instruments for observation. The technological landscape is also dramatically improved since the first interstellar detection in 2017. The James Webb Space Telescope and other state-of-the-art observatories are now available, offering unprecedented capabilities for detailed study. Perhaps even more significant is what repeated discoveries suggest. Before 2017, such objects were predicted to appear just once every few decades. Now, 3 have been confirmed in under 10 years, reshaping those predictions. Many scientists now believe interstellar objects pass through our system much more often, possibly several times a year. Most simply escape notice because they are too faint, too small, or pass too far from Earth to detect. If the frequency of these objects is indeed higher than once thought, it provides key insights into how planetary systems evolve. It means that material is constantly being ejected from forming or aging systems, drifting across the galaxy, sometimes arriving in other systems as silent messengers of their origin. Still, questions persist, despite its bright visibility and detailed observations. The exact classification of this object is uncertain. Is it a comet, shedding faint traces of gas and dust, or a rocky asteroid, or perhaps a type of body we have not yet defined? While its fuzzy appearance hints at cometary activity, it lacks the dramatic, long tail often associated with comets. What it truly is remains one of the greatest mysteries surrounding its passage. And decoding that mystery will be one of the main goals of the months ahead. Some researchers have proposed that the object could be what is known as a pristine comet, one that has never swung close to a star and still preserves its original store of ice. Another layer of mystery lies in its striking brightness. According to Harvard astronomer Avi Loeb, 3I Atlas is reflecting far more light than would normally be expected. If its surface is dark and rocky, like a typical asteroid, then it would need to be immense, possibly 20 kilometers across, in order to shine this brightly. On the other hand, if its surface happens to be highly reflective, the object could be significantly smaller. Pinning down its exact size and reflectivity has proven extremely difficult even with the most advanced observatories. Its rotation poses another puzzle. Normally, objects in space rotate steadily, but data gathered so far indicates that 3I Atlas may not be spinning smoothly on a consistent axis. Instead, it might be tumbling irregularly, as if thrown off balance by some major event in its history. This sort of chaotic motion could be the result of a past collision or a close gravitational encounter with another massive body that left it unstable. Questions about its origins remain unresolved. Was it formed in the relatively recent past around a nearby star? Or has it been drifting anonymously through the galaxy for billions of years? The answer could be buried in its surface characteristics and elemental composition. But current observational tools have not yet provided that level of detail. Perhaps the greatest scientific lore lies in what 3I Atlas might reveal about its home system. Every planetary system imprints a unique chemical pattern on the bodies it produces, distinct proportions of elements, rare isotopes, and particular minerals. If astronomers can decipher these fingerprints, they could indirectly study a system that will never be visited in person. Researchers are also paying attention to whether the object shows any kind of non-gravitational acceleration as it moves through the solar system. Oumuamua displayed such behavior as it exited our system in 2017, sparking heated debates about its cause. If 3I Atlas also demonstrates a similar, unexplained push, it might mean that such effects are a common trait of interstellar travelers. These mysteries make 3I Atlas much more than just another entry in the astronomy catalog. Each careful measurement carries the possibility of unlocking new clues about its past and its nature, with months still ahead to observe it before it vanishes back into interstellar space. Astronomers are racing against time to gather as much knowledge as possible. Of course, whenever something arrives from beyond the solar system, it naturally raises the most thrilling and speculative question of all. Could it be artificial? Could this object actually be constructed by intelligent life from another star? Though this idea often belongs to the realm of science fiction, it has been taken seriously in scientific circles, especially after Oumuamua's unexpected behavior. Avi Loeb famously suggested back in 2017 that Oumuamua might have been an alien sail or probe, its odd acceleration and peculiar shape hinting at possible artificial origins. Now, with 3I Atlas, he has again urged that the James Webb Space Telescope be used to check for subtle evidence of movement not explainable by gravity alone. If any such acceleration is found, it could point to some form of engineered propulsion. Still, it is important to keep expectations grounded. Non-gravitational acceleration in comets is a known natural effect, caused when solar heating turns surface ice directly into gas. The escaping vapor acts like a tiny thruster, giving the object a small boost not accounted for in purely gravitational models. This phenomenon could easily explain unexpected changes in course, what would truly set off alarm bells. However, would be behaviors or signals impossible to dismiss as natural. If the object were to suddenly change direction contrary to physics, emit radio frequencies, or display materials and isotopes that cannot arise through natural processes, then the possibility of artificial origin would have to be taken much more seriously. These would all serve as warning signs that something unusual might be happening. Another aspect astronomers are closely watching is whether 3I Atlas maintains a steady brightness or displays patterns in the way it reflects light. Natural bodies are usually irregular in shape, which causes their brightness to vary as they spin. A more consistent brightness could hint at a smoother, possibly artificial form. While it is scientifically responsible to consider the possibility of artificial origins, history shows that natural explanations are far more common. When pulsars were first detected in the 1960s, their precise radio signals led some scientists to wonder if they were alien beacons. Eventually, they were identified as fast-rotating neutron stars, strange but entirely natural. Even so, the mere possibility, however remote, that we might be studying technology from another civilization is part of what makes these discoveries so captivating. They compel us to confront the ultimate question of whether humanity is truly alone in the universe, regardless of whether 3I Atlas turns out to be a natural comet or asteroid. The very process of testing even radical ideas deepens our understanding. As Carl Sagan famously said, "Extraordinary claims demand extraordinary evidence." Although most astronomers consider it extremely unlikely that 3I Atlas is of artificial origin, they remain alert to any extraordinary evidence as it continues its journey. Observing such an object is no small challenge. Imagine trying to study a dark object that could be smaller than a city yet is racing at 152,000 mph and located billions of miles away. Doing so requires advanced technology, and fortunately, more of it is available today than at any point in human history. Astronomers from across the globe are pooling their resources, using telescopes in locations like Hawaii, Chile, and South Africa to track its position, record shifts in brightness, and study the faint light it reflects for clues about its makeup. Still, the most powerful insights come from observatories beyond Earth's atmosphere. The James Webb Space Telescope, with its massive mirror and superb infrared capabilities, is an ideal instrument for probing such an object. It can detect heat and reveal the presence of specific molecules and minerals. Astronomers have already secured Webb observation time to analyze this cosmic visitor in depth. The Hubble Space Telescope, though older, continues to play a crucial role with its ultraviolet capabilities that complement Webb's strengths. Together, they allow scientists to examine the object across multiple wavelengths. Besides visual study, astronomers are also listening. Facilities like the Very Large Array in New Mexico and the Allen Telescope Array in California are searching for unusual radio signals. An alien broadcast is not expected, but monitoring can still reveal whether the object emits radio waves as it interacts with the solar wind, a constant flow of particles streaming from the sun. As it approaches the inner system, its brightness will increase, and if it is indeed cometary, it could develop a clearer tail. That tail would provide invaluable material for analysis, since it carries gas and dust released directly from the body itself. The detection of 3I Atlas is now seen as the beginning of a transformative era in astronomy. Up until 2017, no confirmed interstellar visitor had ever been seen. Now, in less than 10 years, 3 have been identified. This is not mere coincidence, but the result of tremendous technological progress. Automated sky surveys, highly sensitive telescopes, and advanced software capable of flagging unusual movements have revolutionized the search. The likelihood is not that interstellar objects were rare in the past, but that humanity lacked the means to notice them. Soon, this capability will expand further with the Vera Rubin Observatory, which will capture wide-field images of the sky every few nights. Its enormous digital camera will create a dynamic record of celestial changes, potentially uncovering several interstellar objects each year. The data will allow scientists to answer questions that were once pure speculation. Are most of these wanderers comets or asteroids? Do they originate from interstellar systems or the outer reaches? How frequently are star systems ejecting material into interstellar space? Plans are also in development for spacecraft designed to intercept such visitors. Although 3I Atlas was found too late for a mission launch, agencies and private companies are considering rapid response probes that could be sent after the next detection if identified early enough. Beyond the scientific returns, there is a philosophical impact as well. Each interstellar object is a direct physical link to another star system, proof that material is exchanged across the galaxy. They remind us that our solar system is not an isolated bubble, but part of a larger galactic network, where fragments of one system may eventually travel through another. In this way, discoveries like 3I Atlas not only reshape astronomy, but also how we view humanity's place in the cosmos. And as this interstellar traveler continues on its path, it captures the imagination of all who look up and wonder about what secrets it might hold.